All right, folks, this is your last video or your last notes video in the first section for descriptive statistics. And this one is on quantitative data and displaying quantitative data. So let's just go ahead and jump into it. All right, so displaying quantitative data, you have really four types of plots that we use when we are displaying quantitative data. So we have dot plots, stem and leaf plots, histograms, and box plots. I'm hoping that you have heard of / seen most of these before. So this will be a review, and we'll dive a little bit more in depth into what we do with all of these plots. Okay, so with dot plots, you all are probably fairly familiar with this because we've made a couple of dot plots together in class already. So dot plots, each data point is a dot above its location on the number line. So these are best typically for smaller data sets. Okay, and there's pros and cons to every type, like every display, every chart type. So we're going to talk about those in class a little bit and actually like observe some of the similarities and differences and why one plot is good for one thing versus another, right? But I'll talk about them a little bit here as well. So dot plots are best for small data sets, and part of the reason they're great is because you can see every data point, like you can see every single individual data point. um, so the way that you create them is you draw and label your horizontal axis, and then you just plot each dot, each data point. Okay, go through your data set, put a dot, represent each one as a dot. Okay, stem and leaf plots are where you have each data point represented as what's called a stem and leaf pair. Okay, so your stem, right? Your stem of your data is all of the numbers except the last digit. So all but the last digit. Okay, and the leaf is always the last digit, right? No matter what it is. Okay, one of the most important things about stem and leaf plots is that you always include a key. This is very, very, very important. Okay, so if you look at the example on the left-hand side of your screen here, right? This is a stem and leaf plot. So all of these data points, like these are all individual data points and they're all ages, right? So this one, 2, 5 is someone who was 25 years old. Okay. If you had someone that was 107, for example, they would show up on the stem and leaf plot as 10, 7 right here, right? So the stem sometimes will have more than one digit. That's okay. The only thing that the leaf can never be more than one digit. The leaf always has to just be the one digit, the last digit. So if you have data that has decimal points like 21.9, 15.4, right? Okay, your stem and leaf plot would divide here at the decimal point. So your stems would be like 21 and 15, and your leaves would be whatever your decimal point was. Okay. So that's very, very, very important. So the way that you create these is the best thing to do is whenever you're dealing with a quantitative data set and you have to make anything other than a box plot, so or anything other than a dot plot, so meaning a stem and leaf plot, a histogram, or a box plot, the best thing to do is take the data and write it in order from smallest number to largest number. It will make creating the plot a lot easier. Okay, so when you're making a stem and leaf plot, what you have to do is write all of your stems in ascending order, making sure that you don't skip any. Okay, so an important thing here to note is never skip stems. Whoops. Okay, meaning that right? Never skip stems, meaning that if you have a gap, right, um, you can't just eliminate the stems that you don't want because there's no data at those stems, right? You have to keep those in because what it shows is it accurately shows that there's a gap in the data, and it more accurately shows the shape of the data set. Okay, so write all of your stems, whether or not you have a leaf to go with them. Okay, write all stems. Oops, sorry, I'm getting notifications here. Okay, write all stems in ascending order, draw a vertical line, and then list all of your leaves. And you want your leaves to also be listed in ascending order as best you can. Okay, stem and leaf plots are really great for showing the shape of distributions. Like whether or not it's symmetric, bell-shaped, if it's skewed, if it's bimodal, right? They're really great for that. And what's also great about stem and leaf plots is that you can actually see every individual data point and know exactly what the data point is, right? Because it shows your actual numerical values. Okay, so let me erase this guy. And then let's talk about histograms. Okay, so the one thing that, quickly, I forgot about this. It's easy to see the shape on a stem and leaf plot if you take it and turn it on its side, right? So then it almost looks like a dot plot, right? So you can see like the shape of this distribution. Right? You can see where most of the data is concentrated. Pretty cool. All right, so now let's talk about histograms. Okay, so histograms are look very, very similar to bar graphs, right? Which you can kind of see on the screen there. And I talked about a little bit in the last video on categorical data. Okay, so histograms, what they do is they group nearby values into what we call classes, or you might hear them called bins of equal width. Okay, so on the example that you can see on the left side of your screen, notice no gaps, right? And these bins all are 50 wide, right? See, each bin has an equal width, right? It goes up by 50 each time, okay? So the way you would read this is that in this bin, there are approximately 20 entries or data points. Okay, so there's approximately 20 data points in this bin, approximately 18 data points in this bin, approximately 27 in this bin, and I'm reading this from the y-axis on the side, approximately 50 in this bin, and then I would say approximately 10 in this bin, right? So what this allows you to do is calculate percentages, right? So we could say, if I add all these up, that's 50, 60, 70, 80, 97, 107, 115. So there's approximately 115 total data points, right? So if I wanted the percentage in the first bin, that would be 20 divided by 115. Right, so I could give you a percentage of observations that fit in that bin. Okay, so one of the key things here is that you have to divide your data into these bins, these groups of equal width, so that you can more accurately analyze the data. So you have to divide data into groups of equal width. Okay, and then 5 groups is standard. Okay, so you want to have at least 5. Okay, you can definitely have more than that. The more bins you have, the more specific you can be about your data, but you want to have at least 5. Okay, then what you have to do is to actually draw a histogram is find the count which would be the frequency or the percentage, depending on if you're using frequency or relative frequency, of the individuals in each class, right, or each bin. And then create a rectangle bin, right? Or a bar, essentially. I hesitate to say bar because it's not a bar graph, right? But you create a bin that's tall enough to fit either that percentage of observations or that number of individuals or observations into that particular bin. Okay, very important to label and scale your axes appropriately. Okay, so you don't want to make your bins too small, because then it will take forever for you to draw. And so you want to make sure that you have an appropriate width for your bins, and make sure you label your axes, especially if you're dealing with frequency versus relative frequency, right? If you can see this one on the left-hand side, that the frequency here would be the number in the category, and then the relative frequency is the percentage. Okay, and notice that I know that it looks maybe slightly different, but the shape will not change of the distribution if you keep the bin width the same. The shape won't change really, whether you're dealing with counts, frequencies, or relative frequencies, which is percentages. Okay, so histograms are probably the most common type of quantitative data representation, maybe other than box plots. But histograms are very, very common. So histograms are great for larger data sets. Okay, if you have a ton of data, you don't want to have to create a dot plot or a stem and leaf plot and then plot every individual data point, right? It's a lot easier to group them and then just get the general shape of the distribution. And you can calculate like approximate percentages, okay? It's very similar to a dot plot. But essentially what you're doing is you're representing all of the individual dots in a given range, grouping them, and you're representing them as one large rectangle, okay? Now, it's kind of up to you when you want to use counts, which is frequency, versus percentages, which is relative frequency. But the best thing to do is to use percentages if you're comparing distributions that have a different number of observations, right? Because it allows you, very similar to the conditional distributions that we did when we were talking about categorical data, right? And those side-by-side bar graphs, it's a lot easier to compare the shape and see what's happening if you don't deal with counts, but rather deal with percentages instead. Because if you have one data set that has a very small number of observations, and then you have another data set that has a ton of observations, you may not be able to see the difference in the two distributions based on numbers. But if you do it based on percentages, then you'll have a much easier time comparing the two. Okay, and then I know there's the very last thing on here says box plots. We're going to talk a lot more about box plots in a later video, like in the next section, because there's a lot of stuff that goes with box plots, like interquartile range and quartiles and calculating outliers and all that fun stuff. So more on box plots later. But what box plots do, or you may have heard them called box and whisker plots, they show summary statistics of a distribution. And like I said, we're going to talk more about it later, but they're the ones that look kind of like this, right? Where you have a rectangle in the middle, there's a line in it somewhere, and then it has, has whiskers that stick out from it, right? So this isn't going to show you all of the data points. It's just going to show you some summary statistics about it. Okay. All right. So let me clear this off here. And then I gave you here some data, which is inaugural and death data. I'm going to put a link. There should be a link already for you to be able to see this data more up close, because I only have it in this slide and it's very difficult to see. So what I want you to do here is take a second, pause the video, and try to make a back-to-back stem plot. And I'm going to pause my video as well so that way I can show you what mine looks like. I can insert my picture there. But a back-to-back stem plot will look something like this. Hold on, let me change my pen color so you can actually see what I'm writing. So a back-to-back stem plot will look something like this, where you have the stems. Hold on. Where you have the stems in the middle. Right? And then the leaves from both. So this could be like from the inaugural on this side, and then, or no, actually we should probably go the other direction. So here, you would have the leaves on the left be like the inaugural data, and then the leaves on the right would be like the death data, but you would want your stems to be the same, right? So you would want to look at what's the lowest in inauguration, which looks like it's in the 40s. I don't see anyone in the 30s. So you would start with 4 and then keep going 5, 6, 7, 8, right, all the way up to the largest number in either data set, right? So see, like here, you have a large one. Reagan died when he was 93, but obviously we don't have any presidents that were inaugurated when they were 93, right? So even though that stem does not show up in one data set, you have to have it because it shows up in the other data set if you're doing a comparison, like a side-by-side. One thing that you may want to do for this one would be to split your stems, which I didn't do, and it made my drawing a little bit messy. And here's what I mean by that. So if you look at this data, there are a lot of 50s on here, like a ton of them, right? And same thing for this data set down here. There's a lot of 60s on here, right? You can kind of see them. There's like a lot of 60s, right? So it may be beneficial to split some of your stems and say 4, 5, 5, where you'd have 5 lower and 5 upper, and then same thing, 6 lower, 6 upper. And then you could keep going. You may want to split 7 as well, 7 lower and upper. It's kind of up to you, but I would recommend possibly splitting your stems like this. Okay, so what I'm going to have you do is pause the video, access the document that has this data, the inaugural and the death data, make your back-to-back stem plot, and then compare the two distributions. Like, what do you see that's similar about them, and what do you see that is different about them? So I'll see y'all back here in just a second. All right, everybody. So if you look at the right side of your screen, you can see my back-to-back stem plot. Like I said, I did not split my stems, like my 5, my 6, and my 7. I didn't split the stems, and it probably would have been a good idea for me to do so, because you can kind of see it here. In my 5 stem, there's a ton of data on here that I couldn't even fit it when I was drawing it. So it probably would have been beneficial for me to split those, but there it is. So what's similar about these distributions, obviously, is they have a similar shape, right? If you draw let me increase my stroke thickness here. If you kind of turn it on its side and draw what the shape looks like, right, you can see that it looks like kind of bell-shaped, symmetric, and then same thing for this one. It's bell-shaped, which you would have been able to see a little better if I had split mine, up. Okay, so they definitely have similar shapes, but the death age obviously has a much wider spread, right? The range went from 46 all the way to 93, right? So a much wider range than 42 up to 69. Much wider range there. Okay, and then one thing I want you to notice is that I included a key. Very, very, very important that I included a key. Okay, so 4 as my stem and 9 as my leaf meant 49 years. Very important that you include a key. All right, give me 1 second to erase some things on my screen, because the last thing that we're going to do in this video is draw some histograms, and talk about technology a little bit. So I gave you some data, and I want you to make either a frequency or a relative frequency histogram. I'm pretty sure mine are frequency histograms. And then I want you to set the class width at 2, meaning that, or class or bin width at 2, meaning that each bin has to be 2 PGP wide, and then draw another one where you have the histogram where the class width is 1 wide instead of 2, and I want you to try to talk about what changed. Okay, so let me clear this on my screen here and put this up. Hopefully you can see it. Yeah, I know it's a little hard to see on the one on your notes maybe, but hopefully you can see the data a little bit better here. If you have a calculator, I would recommend that you plug the data into a calculator and use this information right here, the thing on Technology Corner, to make the histogram for you, so that way you do not have to create it yourself. But whatever you have on the calculator, you do have to draw and convert here. Okay, so give this a try, and then come back in just a second and you'll be able to see what your histograms should have looked like. All right, folks, so if you take a look, let me move this over so we can see this a little better. Okay, if you take a look at the right side of your screen, you'll be able to see the 2 histograms that I have here. So the one that's kind of pinkish is where you have a class width of 2. So my smallest PGP value was around 93. I think it was 93.2. So I started at 93 and then made marks along my x-axis going up 2 each time. So 93, 95, 97, 99, all the way up to 107, right? And then what I did is I took the data and I counted how many entries, how many teams fit between 93 and 95, right? And I found out that there were 9 of them, so that's why I have this bin and it's 9 there. I did the same thing for all of the other bins to create this histogram. The one that's blue down here at the bottom is essentially the same graph, but the bin width is 1 this time instead of 2, right? So you can see that now between 93 and 95, there's 2 bins there, each with a width of 1. So 93 to 94, there were 5 entries. 94 to 95, there were 4 entries, and that adds up to 9, which is what it's supposed to be up here. So one of the biggest things that you can see that's different between the two, one is that it's a lot more detailed, right? You have a little bit more information. The shape is about the same. It's skewed to the right, because you've got a lot of data over on the left side and then some outliers possibly, or a little bit of data being pulled towards the right. But it's a little bit clearer about what exactly is going on and the slight differences. There's another thing that you can see in the class width of 1 that you cannot see in the class width of 2, which is these gaps right here. Okay, so when width is equal to 1, you can see the gaps from 99 to 100, like you can see that there's no data there. And the same thing from 104 to 105. You can see that in the class width 1, and you can't see it in class width 2. So just something to think about, all right? Okay, so the last little bit here is about how to use your calculator and how to create histograms on your calculator. So I put some instructions on here. So if you have one of the TI calculators with you, what I would do is take this data set. Oh, sorry, everybody. Take this data set, or you can find another data set and just practice entering the data into a list and spreadsheet, and then follow the instructions to make a histogram so that you can see the data display tools that you have available to you on that calculator. So that you don't have to do all of the sorting into bins and counting and all of that stuff, right? You don't have to do it. Your calculator will do it for you. If you're interested in me making a video about how to do this calculator stuff, please let me know, and I am happy to do that. You just got to let me know. I may also be able to find some online for you already made. All right, y'all. So that is it for quantitative data. And we are at the end now of this first section on descriptive statistics basics. The next section is a little bit more involved. There's a little bit more like calculating that you have to do in the next section. We're going to describe some distributions and calculate outliers and standard deviations and all that kind of fun stuff. So I'll see you all in the next video. Bye, everybody.